Hello, welcome to AP Daily for AP Physics C, Electricity and Magnetism. Today we're discussing topic 9.2, electric potential. And in this daily video 3, we're going to explore the relationship between the graphs of electric field and electric potential. I am Michelle Strand. I am coming to you as an Einstein Fellow on Capitol Hill in Washington, D.C. So let's review how to compare graphs. So remember how the electric field and the electric potential are related, that the electric field is the negative derivative with respect to the position, and the electric potential is the negative integral of the electric field with respect to that position. And remember that a derivative is like the slope of a line. It's the slope of a funky line, right? It's going to be curved. It's not a line. An integral is like the area under a graph. And so the electric field and the potential are very similar to velocity and displacement. But don't forget that negative sign. That is one of the pieces that most people will forget, most students. So velocity can be found, if you remember, from the slope of a position time graph. And so slope is the potential. And then displacement or change in position can be found from the area under a velocity time graph, which would be basically the integral. So a lot of times with electricity and magnetism, it helps if you can connect it to all the material that you understand from mechanics, because it works the same way. So if we take a look at an example, here we have a potential graph, potential versus position graph on our left, and we have an electric field versus position on our right. And we want to sketch the electric field graph from the electric potential. So it's important to remember that the electric field is equal to the negative derivative, which means it's the negative slope. And so if I look at this first section on the velocity graph, that is a positive slope. So I have to take the opposite of that. That's what that negative piece means. So I'm going to have a negative value for my electric field in that section. In this section here, the slope is 0. The potential is not changing, therefore the electric field has to be 0. And for this last piece, now I have a negative slope for this line, but I need to take the opposite, which means I'm going to have a positive value for my electric field. And because this line is steeper than that first piece, it's going to be a bigger value, right? In other words, it's going to be farther away from that 0 line. So that is what our electric field graph would look like from that electric potential graph. So if we take a look at some examples to practice, so this one has, again, we have potential on the left and electric field on the right. This one just has more sections. So again, this piece, if I number them, that might be helpful. So this first one, again, I have a slope of 0. So I'm going to have 0 potential energy here. So this is 1. For this section 2, I have a positive slope, but remember I need the opposite of that. So I'm going to have a negative electric field kind of through all that section. Again, I have 0. And then I have a negative slope here on section 4. And that means I have a positive value for the electric field, and the slope seems to be steeper. So I'll do a little bit up here. And then again, I'm dropping back down to 0. Right. And so these kind of just get connected this way. So that's what the electric field graph would look like. So this next example works the opposite way. And so this one is sometimes more challenging to do, but you can kind of do it, flip it backwards, right? So I have a positive electric field here, which means I had to have a negative slope. So however you want to draw a negative slope, doesn't really matter where it starts because we don't have any numbers, but I need a negative slope because the opposite of that would give me a positive electric field. I have this section where this negative electric field came from a positive slope. And because it's smaller, it wasn't as steep. So maybe something like that. And then this last section, I have an electric field of 0, so I need a constant potential. So notice here that when I have an electric field of 0, that does not mean the potential is 0. It just means that the potential is constant and not changing. So what should we take away? We can always create an electric field versus position graph from a potential versus position graph by taking the negative slope of the line. Creating the flipped version is more challenging, but it's similar to creating a velocity versus time graph from an acceleration versus time graph. Again, going back and referring to what you remember about those kinematic motion graphs. I hope that was helpful. Thank you and have a great rest of your day.